Okay. So for our second half, we have exceptions to talk about. Ravi, welcome. Exceptions to talk about, okay? So, exceptions. What is exception? So, if you hear the word exception, what comes to mind? What do you think about? What do you understand about?
Something not regular.
Something not regular. What else? How else can you describe that? Any other?
Which is not listed as a possibility.
Okay, except yeah, it's out of the norm. It's not expected. Yep. Okay. Errors. So again, bringing close to coding, we are usually talking about errors when we talk about exceptions. Okay. Have you seen this text before? Unhandled exception. You must, because as you code, if your code breaks, usually you get unhandled exception message. You may not have paid attention to that before, but now you're going to be seeing a lot of errors. So this is a very content-driven slide set. I'm not going to go through each and every single slide here. It's available already for you on eCentennial. I'm going to focus on the most important aspects. I will be talking for about 15, 20 minutes. Then you're going to jump into an exercise that you're going to put this in practice. I'm going to be showing some code here. But again, right after that, I want you to get your hands dirty with code there. Okay? So why this is important? Because we want to create robust applications, applications that are resilient, that even though a problem may have happened, but the application did not crash, okay? That the application is able to keep running even after a problem happens in the code, with resources, with anything. This content is available in the book under chapter 11. So if you have the book, it's there. I have also provided plenty of links under week 8 on eCentennial. So you can access that as well if you don't have the book. Okay, so a few standard definitions. Any error condition or unexpected behavior that your application comes through. Maybe those are errors that are logical errors. Something like, let's say you have a division by 0. It's an error. It will throw an error. Maybe you have insufficient system resources like memory. Maybe your application is taking up too much memory. Maybe you are trying to access a file that does not exist. So how do you handle that? Okay? When your application comes across problems, and if you're not handling them, the application will terminate. Okay? Exception handling within object-oriented programming is the way that we usually handle problems. Usually. It does have to be used all the time, but it's one of the many possibilities. Now, as strange as this may seem, problems, errors, exceptions on C#, they become objects. They are classes. So we have classes of exception as well. If I ask you what's the name of the topmost class that we have on C#, the parent of all parents, of all classes, objects. Okay. Now, if I ask you what is the parent of all exceptions? It's exception. Who's the parent of exception? Object. Most likely it is. To be quite honest, I'm not. I think it is. I'm quite sure it is.
All classes in
Yeah, but I was referring to the immediate parents, because every class will eventually get to the object, but it does not necessarily mean that it's directly connected. It's the parents right after that. It's not the grandparent or great-grandparent or ancestor. Anyway, exception is the most generic type of error. Actually, let me revert that. Any error that happens in your codes, you can say that it's an exception. Now, we have specific types of exceptions, okay? Those are just two different types: system exceptions, application exceptions. All exceptions, they end with the keyword exception at the end. We're going to have something like division by zero exception, index out of bounds or out of reach or out of range exception. So there's always the keyword exception at the end of any classes that derive from exceptions, either directly or down the line. Okay? So again, when an error occurs, what happens is that an object that's created, and we can access that error object to get more details about the problem. Okay? Yes? Okay, so let's break that question down. So are there methods for those objects? Yes, there are methods and properties to get details about the problem. Now, are we going to be developing our own errors that I'm going to say, hey, I'm creating a new class that inherits from exception? We can, but we will not be touching there. We'll not be touching that. It's good enough to be able to handle exceptions properly, to be able to create classes that inherit from exception. We could, but we will not be touching that deep into exceptions here. But yes, we have methods, we have properties, and we're going to look at that today. Okay, so just one example of an error: a division by zero is a system exception. You don't need to know that it's a system exception. Just need to know that you can have a division by zero, you can have other types, you can have dozens of different types of exceptions. Okay, let's have a look at this code here. By looking at that code, again, take a second just to kind of read it through and see what could be a potential problem there. Gallon of gas with a division by zero. We're going to have an error right here. Yeah. Anything before that could be an error, that could trigger an exception. Anything before this line here. If we? I didn't get it. Convert to int? What is the problem here? Yep. The user can type a character. A character that is not in a number, a non-numeric character. Okay. True. So again, this could cause another exception. This is something about format exception or something like that. There is a specific error for that one. Okay. So for us to handle those exceptions without breaking the codes, we have to use a block of code. We have to use something called a try catch block. Yep.
So I always thought that when we use convert to int32, like we are parsing, so if it will give, so if it doesn't convert to a number, it will show us the sky value of that character. Is that not true?
It will show what?
The sky value. The sky value.
The sky.
How do we say that? So like the sky value, like for example, for A, it is 60.
Oh, is it the ASCII value here? The int 232 int, the ASCII value?
I used to think that because if it doesn't convert to a number, for example, I write A.
Yep.
And then it will convert A because it's not a number. It will give us.
Convert this. Oh, okay, the ASCII value. I don't know. We can try that, but I'm not sure. I'm not sure. I think it's caused an exception. Are you sure about that, or are you just? Yeah, no, I don't. I think it will cause an exception here. Okay. There are other ways that you can get the ask value, but I think it will cause an exception. We can try that. We're gonna be practicing, and we can try something like that. Okay. So this is just an example of what would happen if you get a division by 0. You're gonna get an unhandled exception because the exception was not handled properly. What does it mean to handle an exception? Well, I'll be jumping around a little bit here, so don't worry about that. I'll show that same code. But now, look, we have a try block. So our code now is located inside this block called try. So what this block does is this. It's going to try to run this code. If by any chance an exception happens, what will happen is that it's going to check, do I have a catch for that exception? Yes or no? If yes, it goes to that block, that catch block. If there's no catch block for that exception, it will raise the exception and the application will quit right there. Now, in this particular example, because we are catching exception is what? Is a class that is the highest class in the exception tree. So all exceptions comes from this class. So no matter what error happens there, this will always catch the problem. No matter if it's a division by 0, if we have entered a character where it should be a number, no matter which error happens, this will always run. This will always catch, this catch block will always catch any errors that happens there. Okay? Let's look at this catch exception E. What does this look like, this line here?
So, what do you mean? So every time when we have 300 divide plus 0, they are going to enter in this exception?
Yes.
We don't need to enter this.
The system, yes. The language knows that. It's one of the mechanisms that the system, the C# itself knows that, okay, this is a problem. Is it inside a try block? Yes, it is. So jump to the catch. Now, here's the other thing. If we get an error like right here in this line, when we read and try to convert to an integer, what happens is that the code stops right there, and those 3 lines, they don't get executed anymore. It skips straight to the catch block. It skips everything down to the closing curly brace here. So those 3 lines, write, gallons of gas, and MPG, they don't get executed. They skip, and it goes to the catch block. If this is the line that gives an error, if it's gallons of gas that gives the error, then again, the last line will not run. So wherever it stops there and gives you an error, it jumps and skips to the catch. If there is a catch that is able to catch that problem, okay? Okay, so here's the thing. Because exception is the most generic type of problem, it catches every single different type of problem. No matter what happens here, this will always catch, okay? Now, we can write specific catches for specific problems, okay? One thing to notice is this. Again, I'll go back to the question that I've asked. This line here, what does it look like? A statement? if statements. Okay, yeah, the try structure as a whole looks like a, no, if this happens, then go there. But just visually, what does this look like? Like a method. It looks like a method that has what? A parameter. Now, our parameter is called what? E, okay? So inside of this block, I can access E, and I can say E.message, E.toString, E.stack. I can get more details about the problem that has just happened, the error that has just happened. This can be E, it can be error, it can, that's in the name, just the name of the parameter. Could be anything, okay? You're gonna see a lot, being called error, being called E. Again, can be called anything you want, okay? And now, if the code goes to catch, to the catch block, you can say E.message. Here, it's not using E at all. So it's kind of useless right now in this scenario. In this scenario here, because we're not using E here at all, we could very much just say catch. And we could get rid of this part. It's the same thing. If I say just catch without the type, it's going to catch any exception. However, it's not going to allow me to get details about the error because I did not declare the exception here. Okay? Again, as we do exercise about that, this will become clearer. Watching coding is not the same thing as doing the code yourself. Okay? Yes?
So in this case, the try is going to have like one error for the convert to int.
Okay.
But they are going to differentiate the error because everything goes for catch, right?
Yeah, so in this particular piece of code, it's not differentiating them.
So everything in the end is going to show you attempt.
Yes, it's going to show this thing here. Yeah, okay?
But this one, the catch must be like a next to the try, or it can be like a try with some codes and then catch after. Must be like a right away.
So it has to be right away. They go together. Try and catch go together. Okay? Now, yes.
So you said if we do not have exception either, it will work, but it would not show what kind of error we got. So that means that when we have E, it goes to exception class, and then it finds what kind of exception it is, and it executes the message from that particular method. Is that true?
Overall, in general, yes. In general, what happens is that if an error occurs, an error object gets created, and if you have declared here as a parameter for catch, you can use that to gather the message, some details about the problem. But again, it's optional. However, we tend to use it quite a lot. The point is that you can have catch without this, and it catches everything, but you don't have access to the object that caught that has the details about the error. Okay? As you code, as you gave it a try, you're going to see the difference, and as we progress here as well. Okay? I want to show. Yes.
NPG equals 0. What is that? What is the purpose of that? NPG equals 0.
It's just doing some cleanup. In the end, catch, what you're gonna do in the catch? You're gonna treat something. You're gonna do something that was being done here. It didn't run properly. So maybe you're gonna clean up some variables. Maybe you're gonna display a message. It's really up to you. What this is doing, it's really doing a bit of a cleanup. Okay, so you have used there, I don't know, MPG here. You try to divide by 0. Maybe when you try to divide by 0, what you really want is make MPG 0. So there is nothing special about this. It's just saying that, okay, set MPG to 0 in case this happens here. Because maybe if you set the gallons to 0, that's what you really want to say is MPG equals to 0. Okay?
And if we do not have the line there, right line, you attempted to divide by 0. If instead of this, I have E.message, as you said,
Yep.
what would be the output?
it will say something about an attempt to divide by 0 was made or something like that. It will give a standard message that comes from C#.
It automatically detects what is the problem.
Yes, yes. So you can say e.message or e.toString or e.stack trace. There are quite a lot of methods and properties that you can access by doing e dot. No, if you put e dots, you're going to see a big list there. Okay? Okay, again, don't get too hooked up in the details. As we're going to go through the exercise, things will become a little bit more clear. Let me show you one more thing here before we jump to the exercise. Look, here's what you could do. You could say, instead of giving the message, you could say e.toString. It will give you details about the error. A standard message there. Now what I want to show is this. This one here. Look. Look at that. We can have more than one catch block. Look, we have two catches here. Each catch will catch a different what? A different error. This one, look at this, divide by 0 exception. This one, index out of range exception. If we run the code that it is right now, what will happen?
Denominator is 0, so
yep.
First one.
So denom is 0, it will trigger an exception here. This line gets skipped, the results equals to array. It goes to the catch, and then we write in first catch block, this is the error. And we write the message. If we change the value of denom to, let's say, 2, what will happen then?
So the result will print, it will divide, and number is 13, and then it will go to the second one.
So the first line here will run properly, but in the array, num is 13. The array has only 3 positions. So we're going to get an index out of range exception. So the second catch will run. Okay? You can have as many catches as you want. Now, you cannot duplicate with the same type of error on them. They have to have different types of errors. Okay? In our example here, we don't have, I don't think that we can have another type of error because it's a very simple piece of code, just 2 lines. But if we had potentially another type of error happening there, would we be able to handle that with this code? But this code is only handling division by 0 and index out of range. What could we do to handle another type of exception in this block here? What could we do? Add another catch block, but this time around, I can catch whatever is not this nor this by using the exception, by saying catch exception error. We could put it down here. Okay?
I have a question.
Yes.
So for example, if I have try and then I have catch, exception 0, exception error, and then I have another catch block, divide by 0 exception.
Inside the catch?
No, so for example, we have first try block.
Yes.
Then we have a catch block.
Yep.
Which has parameters exception error.
Okay.
And then we have another catch block, which is divide by 0 exception error. So which will it go to?
Okay, so I was going to go there a little bit later, but you cannot have the more generic one at the top and the more specific ones at the bottom. You have to have specific, 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 and generic. Okay? Actually, it does not even compile. If you didn't follow that, that's fine. I will be explaining that in more details when I do the demonstration of the exercise. Okay? Yep.
I see the try block is always in main, within main.
Yep.
We can only have the try block in main, or we can have it outside.
Can anyone, I don't know, give your opinion about that? So, can we have or can we not? Is that the only place that we can do it? Is that the main? We can have it anywhere, okay? We can have it anywhere. Try catch block.
Like where we can think that it's a logic part or if there can be an exception. If we are sure there is no exception, just we are declaring the value.
Yep.
There is no need to declare the
Correct. You have to be also reasonable. I mean, someone from another section asked me, okay, so should we have a try catch block everywhere?
No.
It's overkill. It's too much. There will be places that there's nothing wrong here. There'll never be anything wrong here. So you don't have to put this extra layer of complexity just in case. I get it. It will be overkill if you just do it everywhere. Now, there are some places that you should be doing. You should be doing that. For instance, when you are working with files, you want to avoid something going wrong and you leaving the file open. So it's a good candidate to put a try-catch block, okay? Maybe there's a piece of code that is a bit too complex, too complicated, maybe with too many variables, with too many scenarios. So maybe a good candidate to put inside a try-catch block, okay? We're going to explore this a little bit more. Yep.
So I see divide by zero exception must be a class. So can I create when I customize a class myself, can I create something myself and I can extend it from exception?
Yeah, you can. You can. You can extend, you can inherit, you can create your own exceptions. Except that we will not be going that deep with what we'll be talking about. We're going to be using the existing exceptions, but we're not going to be getting to a point that we'll create our own exceptions. But we could do that.
What is more logical? What is more, more rational?
Yep.
To have exception error, just have the general thing, or have multiple exceptions.
Okay, so let's think about that as a group. So what does it make sense? To have specifics like these, or to have a generic one catching all? Actually, let's rephrase the question. How about we just use the general exception and we catch everything? Just throw this big net and whatever comes.
Sometimes we have to define the user-defined exception.
Okay.
In that case, we write these exceptions. If we want to specific message from as user-defined message, then we catch. And moreover, like if we show as a developer, like this exception can be occur. So we define this particular that exception, except just exception.
Got it.
It will depend on this, like how much we are sure.
Okay. Okay.
Yeah.
Good scenario there. What I can say is this. If it depends on the situation, if no matter what happens there, you want the same thing to happen as the catch, you can catch all exceptions by using, instead of specific ones, you can just use exception. You could. However, you may want to deal with different exceptions differently. I'll give an example. There is this exception called I/O exception. I/O exception is an exception that happens when you are dealing with files. So maybe if you catch an exception, an I/O exception, you may want to close the file. But maybe you don't want to do that if it's another type of error. So if you want to handle different errors differently, you have multiple catches. That's really it. No. Does that make sense?
Like if user trying to insert another value and we handle the exception, we
Okay.
can continue our code to allow the user to insert value again.
Yep. It could be that as well. Actually, we're going to go through some scenarios like that in a bit. Okay, so as I said, I'll be, yes? No problem.
So, for example, I have some code in my try block.
Yep.
And for example, the first line is caught by it has an exception, and the catch block catches it.
Yep.
Is there a way that I can execute the code after that exception, when that exception was found?
Okay, so here's the thing. In a try-catch block, if the catch catches the problem, the code will continue to run after the last catch. If there is code here, because in our case there's none. In this case here there's none. But if there's code down here, this will continue because we caught here. So the application didn't stop running. This will happen, and then whatever is here after the try-catch block will continue running. Okay? Again, in a way, we are isolating this block that no matter what happens inside this block, the code after that will still run. Okay? Okay, so now is the time, as I said, I just talked too long here. Now is the time to get hands down, hands dirty, with some exercise. Let's have a look here at Centennial. And under week 8, first of all, at the top, we have some links to additional resources that you can use about exception handling, about throwing an exception, try, catch, and finally block. So again, you can find more information there if you don't have the book. If you have the book, again, that's fine as well. And then what we're going to be doing is we're going to be working on this programming exercises 08. 08, we're going to be doing, at least for now, only exercise 1. It's a simple one. I'm going to give you a few minutes, actually quite a lot of minutes. I'll be walking around. You're going to give it a try. Yeah, we're going to give it a try again. No pun intended. And try to run this exercise there. Okay, so it's a simple one, but it will give you an idea of what it takes to work with exception handling on C#. Okay, so get it going. Give it a try. If you get done too quickly on exercise 1, you can keep going with exercise 2, 3.
So I have in try block, if temperature is this, we return true, and otherwise we return false. But how do I send it that if temperature is in that range, it should go here in this catch below?
Okay, so this is the second one, correct? This is the second? Okay, so it's asking you to throw the exception, correct? So you're gonna use the keyword throw. So look at the exercise. So that's the second one, correct? So Flip back to Centennial. Not actually, let me think here. Yeah, you could keep going down in the slides. Let's see if where does it show. I think it's all the way down where it shows rethrow. Keep going. See, rethrowing. So go back. So you can use. Actually, let me show you a link because it's slightly better described in the link. Go back to the homepage of our course on Centennial. Yep. So go to week 8. Oh, it's already there. So you see, throwing in exception. Click there. So you're going to be using the, scroll down. So you're going to be using this throw. Look at this. This is how you're going to, it's, when you say throw, you are causing an exception. Now, it only, in a way, it only makes sense to cause an exception if somebody else is catching that. If you are the one throwing and the one catching, it doesn't make too much sense. In the exercise, the method will throw the exception, but then whoever is calling the method will have a try there to catch the exception there. So the try is not inside the method.
Okay.
It's inside the main.
Got it.
Okay?
I'll just follow this. Thank you.
Yep.
How do you know what's wrong? Because when it's only 10 index, right?
Yep. Only 10. Yep.
But when I enter 11, it gives me, for example, 1, 2,
Mm-hmm.
11.
But 12. So it gives for 11, but not 12. So let's have a look at the code.
I see. Maybe I should delete this one.
I don't know.
Start
Count
with
it.
0, right?
Well, you don't have to. I mean, yes, it starts with 0, correct. So you read the line there. Value becomes. Oh, but here's the thing. Here's the thing. So you are reading the value, correct? Whatever the user types. Where are you using that? Where are you using that?
Sorry, I think it's
Okay, so you read the value, correct? So int value becomes the value that the user types, correct?
It's the number of the index.
I get it. I'm just saying that based on this line, value becomes whatever the user types, correct? I mean, so let's say 12, okay? So because you are writing the value here based on this test, what should be happening is that value is the index that you should be using right here. See, instead of I, you should be using value here.
The value that the user enters.
Yes. So the value that the user enter is the position inside the array. So if the user entered 2 or 3, is the position. So 0, 1, 2, 3. So if the user entered 3, it will be 0.1.
Yes, this is what happened.
Yeah, but let's have an example here. Let's say that value is 12. Or
12, it's gonna give him it should give him the error message.
it will not. Because your code is not generating an exception. Your code will never generate an exception there. An exception happens when something goes wrong in your code. So I will always be between 0 and the length. Because you're using a 4, so I will never go beyond that. So actually, in a way, you are treating your exception here. You are avoiding your exception there. What you should do, I'll tell you this. Get rid of the if, and instead of I here, put value. Put value directly. But then get rid of the if there. You don't need the if else. So you need that line inside the else, but not the if else. You can paste it. I mean, if you have copied, did you copy that line? Yep. Give it a try. Yep. No problem. What's up?
So the first one here, I don't know if I understood right.
Okay.
So first create array, right, with 10
Yep.
positions.
Then you put some stuff there.
Some stuff there.
Okay.
And then they ask to input for the values, right?
Yeah. You ask for the position. So you ask,
For the
okay,
position.
the user type 2.
2.
So it should show whatever is in position number 2.
On the position number 2 here,
Yes,
right? But
yes.
It's going to be double. This is that because it's going for array, right? So that is going to
No,
be the
but
mistake.
okay. It's an array of doubles. That's fine. But the index inside the array is integer. Yeah.
Yes.
So you're gonna.
But that's why it's going to be the error. Because if he enter, for example, 2 point.
No. If the error is this, if he enters, if the array has 10 positions and he asks for position 11,
Oh,
that's
okay,
the error.
Okay.
Okay.
I thought with like 2.5.
I get it. There might be other errors there, but what the exercise is trying to do is index out of range exception.
Yes, yeah. Because my question is, if he entered 2.5, because here is int, right?
Yep.
Yes, how are you going to? I thought that is going to break.
Got it.
And after, over here, just to display the catch, how we know this class that we enter here? There is a way because you.
How do you know? How do you know what? How do you know that this is the one?
Yeah, that's the one. Like an index out of range. There is a way how we can check how many.
The other ones?
Yeah, the other one.
Well, you can do something like this. Let's see, C#, exception, classes. A bunch of exceptions.
So
Look.
everything, all these classes, they are inside exception.
Not just inside exception. So you see, the base type of those,
okay.
it's system exception, but system exception comes from
inside.
exception. Yeah.
From exception.
Yes.
Okay.
Yes. So, see a bunch.
But you still have like some inside the object too.
Yes. Actually,
okay,
exception itself.
inside
See,
those, yeah.
and then exception, system exception comes from
inside the
exception. Yep.
So, but in the end here to create, so we display there the message, this one, or we display like a message that we.
You can display the message by saying arrow array dots, put the dot there.
It means here.
Yep. It's an object.
Oh.
It has properties.
Okay.
Okay.
Okay. Sorry.
Yeah.
Yeah, they put this.
Got
link,
it.
I don't know why. Oh,
So
and
you
then
see
they give you okay.
a list.
The list.
So you have message, you have tree string, you have stack. Different properties will give you different outputs, but all about the error that happened.
But which one should I choose in this case?
You can do tree string.
Oh,
Tree string
and
will
then
give
the
you
message.
details. Yes. Okay. Yep. Give me just one minute. Okay, so if anyone needs a 5 minutes break, this is the right time, because in 5 minutes I'll demonstrate. So again, take a break if you need. What is that?
How do we intend?
How do?
How do we intend as in?
Indents, you mean? Like tab? Like you select the block? No, but not. I mean, you want to fix everything? Is that? I don't know. Actually, I was asking the other section today if anyone knew how to do that. There is a shortcut to do that. I just don't know.
I Google it, no worries. I just had this question. So this worked fine, but we have this thing temperature, right? This is a variable in this class. Now my question is, I just made it static because I wanted to use it.
Okay, that's fine.
Just make an object and then use
Okay.
it. Yeah.
Okay. So what's your question?
So is this okay, or shall this be generally like private, and then I do not make a property of this, but then what I do is I create an object and then I use.
Okay. So here's the thing. So if you are using this variable here inside. Okay. Let me just have a look at one thing. Scroll up. Why are you declaring this here and if you have it here? You don't need to declare this guy here. Because you're passing temp f in the parameter. That's the whole point of having temp f. No, Control Z, go back there. You don't need this thing here. You need the parameter, but not this. Okay, you're going to pass the temperature. And here, you're going to use this guy. So you don't need the static variable there. Okay?
This worked, the program worked.
It does work?
So yes, okay, it doesn't come up sometimes. I don't know why it doesn't screw. So I say yes, and I enter a temperature, for example.
Mm-hmm.
So I say yes again. I say 30.5.
Yep.
I say yes again. I say 67 maybe. Okay, I think it was 78. It's comfortable.
Got it. Yep, awesome. Good. What's up?
I did this, but it's like it's not.
Okay, so let's see there. Okay. So show me the check temperature. Scroll down. Yeah, so you should throw the exception there.
Okay.
And there outside in the main, you should catch that. You should put that inside a try block. So you throw from the method, then you catch inside the main. Okay? So. Mm-hmm.
I throw the argument search.
How do you throw? Okay, so there's a resource. Can you go to the home page of the course? Yeah, go to content. and then go to week 8. Let's see, throw in an exception. You can have a look at there. And it will show you, scroll down. See, right here, look, this is how you throw an exception. You will use the keyword throw.
And I need to create
You need to throw in the methods and catch that in the main. And catch in the main. We're gonna be doing that when I demonstrate this exercise, and you can ask me the questions there. Okay? Okay, so any difficulties, lots of difficulties, how is that coming along? How things went there? For the first one at least. I'll demonstrate the first one, but then I'm gonna expand the topic on the first one as well, okay? So I'm gonna go through it right now, and again, feel free to ask your questions as I go along. I have Padlet open here as well. So let's start by, here's the project. I have already created the project. I'm going to open the exercise here. So write a program named subscript exception tests, in which you declare an array of 10 doubles and store values in the array. Okay, so let's do that. Again, many different ways that you could declare this. I'm gonna just use double array. I'm gonna call this my list. And then I'm gonna initialize with 10 positions, 10 values, 10 different values here for the double. So I'm gonna go we have 5. So we have 5 there, and I'm gonna add 5 more. Okay, so I think I have 10 now. 1, 2, 3, 4, 5. Yeah, I have 10. Okay, so here's the array. Write a try block in which you place a loop that prompts the user for a position value and displays the value stored in the corresponding array position. So the user will type 2. We're going to go in the array. We're going to get the value of position 2. Okay? Create a catch block that catches any index out of range exception and displays the appropriate message. Okay? So let's write the code first, as there will be no exceptions. So it says loop and prompt the user to enter a value. So which kind of loop should I use there? A for? Anything? A while? Well, the exercise is not very clear to which type of loop you should create. But I can tell you this. It says that you should be asking that to the user. It doesn't say how many times you have to ask. So a for, it would limit the number of times that you would be asking. So what if we do this? Let's get to a loop that will keep asking the user to type a value. And then eventually the user may decide, I want to quit this. So maybe we're going to say, if the user types, I don't know, 22, 55, 99, we're going to stop there. So let's do this. Let's go into a loop. But let's do a while. So while something here, we're going to do something else. So while what? While, let's say that we're going to store the value that the user inputs in a variable called position. So let's declare a position here. So let's say int position equals to 0. Let's initialize this. And then I may say while position different from 99, do this. Now, let's practice what we preach, which is, let's not use magic numbers. Let's take this 99 here and convert that to what? To a constant. Okay, so let's do this. Const int stop equals to 99. And I can say while position different from stop. Keep doing this. Okay? Now, what is this? Well, we're going to be asking the user for the value, and you're going to be accessing the position in the array. Again, different ways to handle this. For sure, each one of us will have a different solution when we put this together. And all of them will be correct, most likely, okay? So, here's what I could do. I could ask the user to type already, right here, the first position. I can say console.readLine. And I'm going to convert this to an integer. I'm going to say parse. So you're going to get the first value. If it's different from stop, what you're going to do is you're going to write a message. You're going to say console.write. And you're going to say, yeah, so actually, here's the thing. Right now, I got the first position. So I'm going to display what's inside of that position. I'm going to try to display. I'm going to say value at position and then position is, now I'm going to use the array name, and then in a bracket I'm going to say what is the position? Well, the position is this one. So I'm going to grab the value, the double value in that position. Okay? How does that look like? Looks okay. What else should I add here? What else should I do next? Again, let's forget about the try. Let's forget about the try for now. We are just trying to make this loop through. So what could I do next here? So should I read again? Maybe. I should read position again. So I can say position, read it again. But there is no message here yet. So how about we put a prompt that says, hey, type the next position. So you could say something like this, console.writeLine, and I could say, enter the position number. So I'm going to ask the user to enter the position, and I'm going to do the same thing here too, because otherwise we're going to be staring at a blank screen. Okay? So I think that this should work without try yet. So I'm just going to run this. Enter position number. Let's say 1. Value at position 1 is 23.32. And 9, 8. Again, all good. Now, if I try to enter a position that does not exist, look at this. Unhandled exception. That's the entire name of this section here is exception handling, how to handle exceptions, okay? So, it throws an exception. It even tells you, look at the name of the exception. It's right there. It tells you the line as well, that the problem is happening. But of course, this broke the application. The application stops working. We don't want that. Actually, let me just do this. Okay, now, if I ask you, where should I add the try block? What is it?
Before while.
Try block will be outside of while or inside of while?
Outside. Outside.
Actually, you know what? It depends. It depends on what. What is the difference? The question is, what is the difference between putting the try block inside or outside? What's the difference?
Because if a position is something out of the bound already at the very first place, it's not going to give an exception. If we have try at the very beginning, before while, it's going to try that. If that doesn't happen, it's going to catch it. Otherwise, if it is inside while, it's going to be doing while, but it will not be to catch exception.
But the position we are taking inside the while. We are trying to test the position inside the while, not outside the.
Yes, that makes sense. So we can have a derivative.
So there's no difference? Of course, the difference, we're going to be positioning things in a different place. But is there any logical difference? Will the program behave in a different way if I put it inside or outside?
Inside it's gonna call again and again. But if you put outside, then it's better. Why?
Why? Actually, it depends on what you want to do. If you want the codes, if an exception happens and then you handle that, but you stop looping, you put it outside. But if an exception happens and you want to keep asking, you put it inside. So the way I interpret the question, the exercise, is that even if there is an exception, keep asking. So for you to keep asking, we have to put the try block inside the while. Because otherwise, if you put it outside, it's going to catch, it's going to go to the catch. The catch is already outside the loop. So, yes, we're going to handle, but we're not going to be back in the loop again. We're going to be, let's do this. Let's start by implementing outside, and we're going to see the difference. Look, I'm going to put try. And then I'm going to catch here. For now, I'm just going to write it like this. I'm not going to put the exception there. I'm going to just do this. Okay, so let's see. So if I put 3, 5, 6, 2, all good. But if I put, let's say, 23. Okay, so it didn't give us an exception, but of course I missed doing something inside the catch. So let's write a message here. Let's do something like this. Index not available. So again, All good, but then it should be a right line, but that's fine. So here is the message, index not available. And then it quits, it stops, okay? Now, if I want to keep asking, I need to move the try inside the while. So I need to do this. Well, trying to see what I can copy and paste in the best, most efficient way here. So,
After position, catch, try.
so I could put try like this. Let's see.
And then catch.
And then the sketch after that. So we have try catch here. So will this keep asking?
Yes.
Okay, let's see how it works.
You did not write position again. Oh, you did that. You did that.
So I'm trying here, and then let's see how this goes. So 2 okay, 4 okay, 55. Ooh. So what happened here? What happened here is that it gives an error, it goes to catch this catch here, it goes all the way up. Actually, what happens here? Let's see why it's doing that.
Yes, because you're not reading except, so you need to have a position again after the catch.
Oh yes, of course. So I need to ask again. But here's the problem, here's the thing. How can we solve this without duplicating the same line of code?
Find the assign the position value.
Or maybe after that, this after catch, have this line position equals input.
Yeah, so we duplicate that. We don't need to duplicate, we can just move this. We can just say, we can just move this here. Okay? We can just move out. So we try it here. If it works, great. We're going to ask again. If it doesn't work, that's fine. We're going to ask again. We're going to ask in any case. Okay? So I'm going to run again. Again, Sunny. Whoops. We're not catching that exception. So now 55. Index not available, enter positions, and it goes like that. So now it works. I can put invalid positions, and we're just going to get the message. So did you see that now we're catching this problem here? We're trying this block, and then we are catching right here. And we keep doing that until, again, the 99, I didn't even try 99 here. So 8 okay, 99 quits, okay? So is that making sense? I mean, anything muddy there, anything hard, anything that is getting you stuck by any chance that you're not following? Anyone? Okay, so with that, the exercise is done. But I want to expand on that. I want to explain a few more things by expanding this exercise, and you're going to be able to apply that to the next exercise as well. Here's the first thing. Look, I'm just using a simple catch. I'm not declaring the exception here. So I can say this as well. Exception, E, or error. Now, with error being available, well, first of all, Visual Studio is telling me that right now I'm not using this. So I might as well just get rid of it. Of course, I just wrote it. So I'm just going to say here, index not available. I'm going to say console write. I'm going to write another line here, another message. I'm going to say error details. And I'm going to say error dot. Then you have dot message, you have dot toString, you have dot stack trace. Each one of those will give you more or less details about the problem that happened. So I'm just gonna, for the sake of this exercise, I'm just gonna call dot message. And I'm gonna just highlight this a little bit better. So I'm gonna say, I'm just gonna put some dashes here that makes it very clear that an error has happened there. So if I run this, okay, regular case, but if I put an invalid number, then it says index not available, error details, index was outside the bounds of the array. So that's what the property, the message property has. But let's see the other ones. Let's see, for instance, stack trace. So, all right, invalid number. Look, stack trace gives us the line of the code that triggered the exception, including the file name as well. So you can go straight there. Now, of course, if you are creating an application for an end user, you're not gonna put that, okay? Because he or she will not have any idea of. But here's the thing: maybe you send an email to the sysadmin of the application with that line, so he or she can yell at the developer, you. Okay. Anyway, so you can give a try on different properties there. They'll provide different level of details about the error. What else? What else we have here? Okay. Instead of this catch, we can also, if we are just worried about that type of exception, we can catch a very specific exception. Actually, the exercise, to be quite honest, actually, the exercise was not done because I was using exception. So I needed to use this one. So I have to use index out of range exception. And I'm going to call this error as well, because they all inherit from exception. They have a message too. So nothing changed here. I'm just catching a more specific error. Okay? Now, I could put both of them. I could have one catch for this one and another catch for the exception. And I could say here another problem. I could use message, that's fine. Now, of course, our code is very simple. Nothing else wrong will happen here in this line, aside from the position being outside of the range, okay? Yes?
What if they put in like a string?
Now, that string thing, it's another problem that is outside of here. It's right here. So we would have to handle it right here. Maybe we put another try here. We can have multiple tries, or we could potentially move this inside and have a duplication. Again, there are different ways to solve, but typing a character instead of a number is another problem that we would handle most likely separately here. Okay? But we're going to force a problem here. Here is the thing, we're going to force that. So we have index out of range here. But what if we force, just for the sake of example, we force division by 0 here? Let's try this. Let's say we have int I equals to, I don't know, 2 divided by 2 minus position. So what is the situation that will cause a problem here? Position 2. So if I put position 2, 2 minus 2, 0, division by 0. So let's see what will happen here. In this case, what is the error message that will show up? The second one. So let's give it a try. Again, 3, 4, but 2. Another problem, error details attempted to divide by 0. Okay. Again, I'm not saying that this makes logical sense. I just forced the situation here that we could use to demonstrate the second catch. Now, I could have a third catch. I could have a division by 0 exception. And I could say, okay, you cannot divide by 0. Okay, so okay. Okay, so divide by 0. So now we have 3 blocks. Now, again, when we try this once again, by 2, we have that specific one. You have asked before if we could move this up. The more, I mentioned that the more general one needs to be at the bottom. So if I try to move this up, we get a compilation error. See, it doesn't even compile, okay? Because it says, hey, you have the more generic one at the top. If that is there, we will never be able to reach this one nor this one, okay? Yeah, to catch all of them. So it doesn't even let you compile the application, okay? Okay. Okay. What else we have here? So there are 2 other points that I want to make sure that I cover.
If the position is a negative.
It will fail as well. Well, let's try that. I think it will be invalid position as well, but let's try. So -1. Index outside the bounds. So it triggers the same one. Okay? Yep. Go-to, the go-to keyword, does it exist in C#? I don't know. Does it? Okay, so if it exists, go-to has almost been abolished many years ago because it makes the code very complicated to follow. So have you ever used go-to? You have? When? Yeah, I'm just saying that because go-to, I mean, even I can tell you 20 years ago when I started coding, go-to was already bad-mouthed back then because go-to makes the codes very complicated to follow through. So again, I didn't even know that C# still had that or had that available, but don't use go-to. Don't use it. It makes the flow of the codes too messy, potentially, too messy. Because you can do crazy stuff with go-to. You can point the codes to various different positions. So avoid that. in a job interview, please don't mention go-to. Don't. Just don't. Forget about go-to. Actually, I forgot about go-to until you remind me of go-to. Go-to, again, it's a pet peeve. It's something that I don't know why they put in C# go-to. Now, I don't like C# anymore as I used to like, because now I know that it has go-to.
But does it work as a loop?
What is that?
Does it work as a loop? Go-to?
It works as anything you want it to work. I mean, again, it makes things a lot more complicated than they should be. The flow of the codes, you can be jumping around. I mean, go-to can point you to anywhere else in the code. So let's forget. I'm gonna delete this part in the recording. From the recording. Anyway, let's move on. Okay, so with that said, so where was I? Okay, so two things that we need to talk about still before I let you guys go. One is throwing an exception. So for exercise 2, you have to get to know about one little keyword called throw. Throw is when you, based on some circumstances, you want to throw your own exception. You want to say, hey, if this happens, I want to force an exception here. Okay? I'll give you an example. Actually, in our case, because we only have the main methods, it's not super practical or applicable, but if we have multiple classes or another class using, we have main using another class that we may have created. Let's say that this class has a method that accepts a parameter that is an integer, but it has to be positive. If the user sends a negative value there, I can throw an exception. I'm going to say, hey, I don't want negative numbers here. The way you use throw is something like this. I'm going to force again one situation here. I'm going to say, let's say our numbers here. So the numbers are, the first 5 are above 10, the second 5 are below 10. I'm going to just force a situation here. I'm going to say, if the value, again, I'm really forcing this. If the value is above 10, I'm going to say, it's just one line, I don't need anything. I'm just going to say, throw what? When you call the keyword throw, you have to create a new exception here. So I'm going to say throw new exception. And I'm going to give a message. I'm going to say, just for example, no values above 10. So with this line, what we are doing is, if this happens, throw an exception. And then, again, which one here will catch that? The last one. The last one, because we're creating an exception. Now, here's the thing. We could create any one of those exceptions. We could force any one of them, okay? So what this is, we are throwing an exception. Now, in our case here, or usually, to be quite honest, it doesn't make too much sense to throw an exception inside a try, because you are throwing and you are catching at the same time. Usually throw makes sense when you throw, think about a ball. You throw the ball to somebody else to handle that. Like you have that in exercise 2 will help you with that. Again, it's already a lot, I get it. But exercise 2, as you go through exercise 2, this will become a little bit more concrete. You're going to visualize this better. But throw, you are forcing an exception to happen. You are saying, hey, I don't accept this. I want to throw the exception, and somebody else needs to pick this up. In my case here, in our case, we are picking it up ourselves because we are putting this inside a try block. So if I run this, if I put values above 5, it's okay. But if I put 1, so it says, whoops, what was the problem here? Oh, yes, of course, it's right. Another problem, error details, no values above 10, because we send the message here, see? Anyway, I'm not gonna go for too long here. This is how we throw. Exercise 2 will help you to understand this better. Also, there is a link on the Centennial that will point you to throwing an exception. I would recommend that before you go to exercise 2, have a look at this link so it will guide you through that as well. Finally, as a final comment, we're going to talk about, well, finally. Yes?
So it says that if minus position is greater than 0, then throw this exception. But it was 1. The position was 1.
No, but yeah, it's not the position that I'm comparing, it's the value in the position. Okay? So there is a block called finally. So finally, well, no puns this time. So what is the point of finally? Finally is a block that will always run, always, no matter what happens up there. No matter if try worked fine, if try had a problem and catch runs, if try had a problem and there is no catch to catch that, in any case, finally will always run. There is a slide that talks about that one, and I will show it quickly here. See, finally block executes no matter which of the following outcomes occurs. The try ends normally, the try ends abnormally, and the catch executes. The try ends abnormally, and the catch does not execute. And the try ends abnormally, the catch executes. Well, that's already too much. Because what may happen is that you may have a problem inside the catch. What if your catch is causing another problem? It may happen. Anyway, too many problems already. So the point is that finally will always run. And it's usually used to, let's say, to close a file. You always want to close the file no matter what. You can close the file inside the finally block. So again, try, catch. So in summary, we have one try, potentially multiple catches, and optionally one finally. Because finally is not mandatory, it's optional, okay? Who's tired? Anyone tired? Or just me? Maybe just me. Let's stick around for another hour. Okay, so that's about it. Have a look at the exercises. Next class, we're gonna start reconnecting with those exercises. Towards the middle of the class, we're gonna do the quiz, including exceptions and polymorphism, inheritance, about 6 to 8 questions, okay? Assignment 3 is released, so I mentioned it already. That's it. Any questions, anything? Okay, have a good weekend. I'll see you all next week.